Alright, boys and girls, welcome back to the drive-thru for a remix. Another shout out to John and Nick doing some math. We're doing this all again because it looks like they have slightly, and I think accidentally, changed these functions from our prior video. But let's just get this right and we're going to move on, no big deal. Let's take a look at a of x. We know that I've looked closely at that, and the y-intercept for a of x is 28,000. Okay? To find the slope, we need to figure out, well, it looks like these 28,000 gallons have been drained in 20 minutes. Okay? Keep in mind, we've lost 28,000, so it is a negative. So that is negative 1,400 gallons per minute. Okay? And that makes a of x, is negative 1,400x plus 28,000. Alright, now let's look at d of x. Again, it's easy to figure out the b for d of x. It looks like 24,000. So to find the m, we got to figure out, well, how many gallons per minute? It took 24 minutes for this 24,000 gallons to drain. So that is negative 1,000 gallons per minute. So d of x is negative 1,000 x plus 24,000. Okay? So, g of x is a of x plus d of x. So what is negative 1,000, or negative 1,400 x plus 28,000 plus negative 1,000x plus 24,000. So let's combine like terms there, and you'll get, I'm sure they're going to ask for this later, but I think this is a good way to do it. You're going to get a negative 2,400x plus, what's 28,000 plus 48,000? 52,000. So what does g of x represent? I think it represents the total water in both pools at any given minute. Okay? It wants us to create a graph of g of x on a new set of axes using a of x and d of x, and then identify g of x. Okay, so they want us to graph this. That's g of x. Let's get a new screen. Negative 2,400 x plus 52,000. So if we just made ourselves an axis, let's see. I need to start at 52,000. So let's go up by 10,000. So this is 10,000, 20,000, 30,000, 40,000, 50,000 gallons. And this is gallons for our unit. Okay? Looks like we're going to need, well, I think we know that both of the pools will be drained within 24 minutes. So for mine, I'm just going to go over by fives. 5, 10, 15, 20, 25. And let's just copy these real quick. So at A of x goes from 28 to 20. Whoops. A of x goes from 28 to just a little shorter to 20. D of x goes from 24 to 24. Okay. So that is D of x. And now let's graph G of x in green. Well, it goes from 52,000, and the slope is negative 24,000. Well, let's figure out, where does that thing equal 0? Okay, well, I need to solve this thing. So add 2,400 to each side. And you get 2,400 x equals 52,000. I got to bust out the calculator on this. So if I divide each side by 2,400, I get x is 21.6 repeating. So 21 2/3 hours. So if we could add these pumps together and pump both of the pools with the same pump at the same time, that would be how long it would take for the water to drain. Now let's go back to our targeted questions. Write the equation for g of x, and using your graph, compare this equation to the algebraic representation, finding the sums. Okay? I feel like we did that. I'm going to skip over that one. Should the algebraic equation of g of x be the same as the algebraic function created from the graph? I would say yes. Use both graphical as well as algebraic representation to describe the characteristics of g of x. Okay, so they just want us to go back. We've done that before, but not with g of x. So what's g of x? Well, b is 52,000. M is negative 2,400. Okay, the domain is 0 to 21.6 repeating. The range is 0 to 52,000. Okay. Explain why adding the two values of the y-intercepts together can be used to find the y-intercepts. Well, I think the original water in pool A plus the original water in pool D will equal the original water in the sum of those two pools. For the x-intercepts, it's not the same because the slope of both equations were different, and what that created was a spot where we had to kind of average their slopes, creating a third new slope. So you were able to add the y-intercepts, but slope is a rate, and so those aren't something that you could just simply add. All right, I know you're going to have questions on the homework videos, so please put those on the request boards so I can help you guys move on with success and not just move on. The goal is not to get it done, it is to understand. You're doing so well. Boom!